So in this topic we're going to study about the inverse functions. The opposite of square is square rooting. If we need to take the square of a function, square of a number like 2 square, so the opposite of it is square root of 2. If we need to opposite of multiplying is by 2 multiplied by 2 is 4, so 4 divided by 2 is 2. When you find the opposite of operation in order to undo a function, that you are finding its inverse. So we are going to study about the inverse function. Let's do a warm up. Okay, think of a number. Let's suppose I think of the number 8. Subtract 3, I will get 5. Now I will add 3, I will again get 8. So f of x is equal to x plus 3, g of x is equal to x minus 3. Are inverse functions. They undo each other. If f of x is x plus 3 and g of x is x minus 3, graph the linear functions f of x and g of x on the same grid. Use the slope and the y-intercept or a table of values to help you out. So the function f of x is x plus 3. So function y is equal to x or f of x is equal to x is this. So x plus 3 would be 3 lines upwards. 1, 2, 3. This will be the function f of x, and g of x would be 1, 2, 3 downwards. This would be g of x. Okay, what do you notice about these graphs? These graphs are a reflection of each other over the line y is equal to x. Reflection of each other over y is equal to x. Okay, consider a function machine that takes an input value, doubles it and subtracts 5 and sends out the result. Write an equation for this and put it aside inside the function machine. Okay, so what is the function machine doing? Function machine, consider function machine that takes an input values. Let's suppose it takes an input values x, doubles it, subtract 5 and sends the results out, and this would be the output of f of x. So the function machine either has the equation f of x is equal to 2x minus 5. Find the result when the input value is 3. So if we will put the input value 3, it would be 3 times 2 is 6 minus 5 is 1. So the answer would be 1. How could you change this result back into the input value 3? What operations would you perform and in what order? Can you write an equation for the inverse function? So for the inverse function, what we're going to do is 1 plus 5, which is going to be 6, and 6 divided by 2, which is going to be 3. So, or we can do it like this. For the reverse function, we're starting with 1. So we're going to add 5 and 1, we will get 6. So we will divide 6 by 2, we will get 3, which is the output, and this is the input. So can you write the equation of the inverse function? The equation of the inverse function will be 1. What is when? This would be x plus 5 divided by 2. This would be g of x, the other function, the inverse function. If f of x was the function and g of x is the inverse function. So f of x is 2x minus 5, g of x is x plus 5 by 2. Find f g of x. To find f g of x, f, what is g of x? X plus 5 by 2. So now the new x is x plus 5 by 2. So it's f of x. So what is f of x? 2 x minus 5. So it's x plus 5 minus 5, which is equal to x. Okay. So now compute g f of x. Okay. G, what is f of x? 2x minus 5. So now the new x is equal to 2x minus 5. So it's g of x. It's g of x, and g of x is x plus 5. What is x? 2x minus 5 plus 5 divided by 2. So what do you notice? That fg of x is equal to gf of x. Okay. Properties of inverse. If the inverse is a function, then we use the notation f inverse x to denote the inverse. If a given function f of x is 1 to 1, then its inverse will also be a function. The graphs of inverse functions are reflective of the line y is equal to x. The graphs of inverse functions are reflective over y is equal to x. Okay. And if a given function f of x is 1 to 1, then inverse will also be a function. If x and y are coordinates of the original function f of x, so we have to get the graph of the inverse function f inverse x. Okay. Consider the set of the points. Plot the set points on the grid provided. Okay. 4, minus 3. 4, 1, 2, negative 3. 2, negative 1, 2, negative 1. 7, 0, 7, 0. Minus 1, 4. 2, 10. Okay, so these are the set of points that I have plotted on the graph. So what is the domain of this set of points? So we have already learned about the domains. The first elements are called the domains. All the first elements are domains. So it's going to be 4, 2, 7, minus 1. Again it is 2, so we can write it one time. What is the range of the set? The second elements are called range. Switch x and y to write the inverse set. So let's write the inverse set. Minus 3, 4. So if it is 4 minus 3, switch like this. Okay. Minus 1, 2, 0, 7, 4, negative 1, 10, 2. State the domain of the inverse function. Now the domain would be minus 3, minus 1, 0, 4, 10. And the range would be 4, 2, 7, minus 1. Do you notice that? What do you notice about the domain in the range of the inverse functions? The domain of the original set becomes the range of the new set, and the range of the original set becomes the domain of the new sets. Domain of original is equal to range of new set. Range of original becomes the domain of new set. Consider the relation graphed below. Just this graph represents a function. For a function, we need to do the vertical line test. And what was the vertical line test? We need to plot a vertical line. It should cut the graph only at 1 point. So yes, vertical line test passes. Is it 1-to-1 function? For 1-to-1 function, what you need to do is put a horizontal line, and it should pass to, if it's passing more than 1 point, so no, horizontal line test fails. Okay. So because we are going to we are doing the revision, so you already have watched all of my previous videos in which we have learned in detail that what is vertical line test, what is horizontal line test, and you already know that what we are working for. Okay, so x and y. Sketch the inverse function on the same grid of x and y. So for the inverse function, what we're going to do is put the x values, y values for the x, and x values for the y. Okay, now let's plot 3 and minus 9. 1, 2, 3, and 2, 3, 4, 5, 6, 7, 8, minus 9. 7, 4, 5, 6, 7, and minus 7. Minus 3 and minus 3. Minus 3 and 2. 3 and 8. So the inverse function is this, 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 this. Is the inverse relation also a function? So about the inverse relation, it's not a function, because if we will draw a line here, it touches vertical line test is failed over here, so it's no, vertical line test fails. Consider the relation below. Consider the relation graphed below. Just this graph represents a function. Okay, so vertical line test. Yes, the vertical line test passed. So yes, VLT passes. Okay, so is this graph one-to-one function? So I think yes, it is passing horizontal line test. Sketch the graph of inverse on the same grid. So to sketch the graph of the inverse on the same grid, what you need to do first of all is you need to get all the y and the x values opposite. Okay, if it's 4 and 4, so the opposite would be again 4 and 4. It's the same point. It's 0 and 3, so opposite would be 3 and 0, so it would be 1 2 3 and 0. Minus 1 and 1, it would be 1 and minus 1, so it would be 1 and minus 1. Minus 3 and 0 would be 3. 0 and minus 3 would be 0 and 1 2 minus 3. Minus 4 minus 2 would be minus 2 minus 4, it would be minus 2 minus 4. Okay, so this is the graph. It's an inverse relation of function. So yes, the inverse relation is a function too because it passes a vertical line test. How does this compare to the last problem? The original function of the present question is not one-to-one, but the other one is one-to-one. Finding the equation of an inverse algebraically. Oftentimes, we can find the equation for the inverse by reversing the operations of the original function. Sometimes it's not so obvious and we need to algebraic approach to find the equation of the inverse. So first of all, how to find the inverse is switch x and y and then solve for y. So f of x is equal to 2x minus 1. So we will write y is equal to 2x minus 1. Then switch x and y will become x is equal to 2y minus 1 and then solve for y. This is the inverse of this function. So very easy. Whenever you need to find the inverse, what you have to do is switch x and y and then solve for y. Okay, part B is g of x. So let's write it y is equal to minus 2 x minus 5 over 6. Switch x and y. We will get x is equal to minus 2 y minus 5 over 6. It will be 6x minus 2y plus 10. 6x minus 10 is equal to minus 2y. 6x minus 10 over minus 2, which is equal to y. So this was the, we can just write it 2 3x minus 5 over minus 2 is equal to y, which can be equal to minus 3x plus 5. So I'm writing over here g inverse of x is equal to minus 3x plus 5. Okay, so write y is equal to f of x. Okay, y is equal to 1 by 3x plus 2. Switch, put y कीजिएगा x and in replacement of x put y. Now solve for y. Now why I'm writing f inverse x over here instead of y? Because I'm just solving it here. We're writing f of x is equal to y, so x is going to be equal to f inverse. Okay, so it's y is equal to minus 2x plus 4. Now switch, put x is equal to minus 2y plus 4. Here I have switch. So I will write x minus 4 divided by minus 2, which is equal to y. So f inverse of x is equal to minus x minus 4 by 2. Extension. Proving functions are inverses. If two functions are inverses, then they will undo one another. As we saw earlier, f of x is equal to x plus 3 and g of x is equal to x minus the inverse of each other. This means that g of x will undo whatever f of x does an input value. Let's try with x is equal to 2. So the first question here we have 2. So 2 plus 3 is going to give us 5. Now undo it. We will take 5. 5 minus 3 is going to again give us 2. So g of f of 2, g of function, in function f we put 2, and in function g f of 2 we will get the answer 2. So 2 minus 3 is minus 1. Here minus 1. Minus 1 plus 3 is plus 2. So g of 2 will result in fg of 2. It is a proof of f of x and g of x are inverses. What about when x is equal to 0 or x is equal to square root 3? Simply, we cannot possibly tell the input values to verify two functions are inverses of all for all values of x. We will prove that the inverse are more generally using x as an input. So this is where function composition comes in handy. F of x is equal to g of x. So compute f or g or x, which can be equal to f g of x, which can be equal to f g of x is x minus 3, which can be equal to f of x, and f of x would be x plus 3, x plus 3, which is equal to x. G f of x, which is equal to g, and what is f of x? X plus 3, and g of x is x plus 3, which is equal to x. So f for g x and f g of x and g f of x are inverses for one another. So because both get the answer x. Okay. If we are asked to prove or verify inverses algebraically, use the following theorem: f g of x is equal to x and g f of x is equal to x, and f of x and g of x are inverses. If both will get the same answer, it means they are inverses. If f g of x and g f of x both get the same answer, it means they are. So use function composition to verify whether these are inverses or not. So to verify, first of all we will find out f g of x, which is equal to f, what is g of x? 3x minus 2. So f of x, what is f of x? 1 over 3 x. What is x? 3x minus 2 plus 2. So it's going to be x minus 2 by 3 plus 2. Okay. Now it was f g of x. Now we will find g f of x, which is equal to g 1 by 3x plus 2, which is equal to 3 x is 1 by 3x plus 2 minus 2, x plus 2 by 3 minus 2, 1 3 is 3. So they are not equal, so f of x and g of x are not inverses. Okay. Now f g of x, which is equal to f minus 1 by 2x plus 2, f of x minus 2 minus 1 by 2x plus 2 plus 4 minus minus plus, and it would be x minus 2 times 2 is 4 and 4, so we get x over here. So now g f of x, g minus 2x plus 4, and g of x is equal to minus 1 by 2 x plus 2 x minus 2 plus 2, which is equal to x. So here f of x and g of x are inverses. At right is a picture of Anita's function machine. When she put 3 into the machine put out a 7. When she put a 4, machine gives her a 9. When she put minus 3, she comes up with minus 5. So what is happening? When she put 3, she gets out the machine is 7. So 3, it was adding, when she was putting 3, she was getting 7. When she was putting 4, machine gives her 9. When she put minus 3, machine gives her minus 5. So what's happening? 3 times 3 is 9. 3 times 2 is 6 plus 1 7. So it can be 2x plus 1 is equal to y. 2 times 3 is 6 plus 1 7. 4 times 2 is 8 plus 1 9. Minus 3 times 2 is minus 6 plus 1 minus 5. Suppose it were possible to turn the crank in the opposite direction, causing the machine to pull out the outputs back up and undo the effect of the first function machine. That is what she wants: a machine that will take 7 and turn it back to 3, take 9 and turn it back to 4, and so on. Writing the rule, what program should the new machine do is y is equal to 2x plus 1 was the first machine. So switch x and y to y plus 1. Solve for y. So the new machine will do this thing. Find the inverse for each of the function, for each of the relation. Okay. Just do the opposite. 3 1, 3 minus 2, 1 5, 4 6. For each function below, sketch a graph of the inverse on the same grid. Can you see the reflection in the line y is equal to x? Okay. So the point, this point is 3 minus 2. This is 0 minus 3. This is 4 3 6 1. So the inverse would be 3 minus 2. Inverse would be minus 2 3. Zero minus 3 would be minus 3 0. 3 4. And 1 6. I'm going to plot it again. Okay. Minus 2 3 1 2 minus 2, positive 3 1 2 3, minus 3 0, 3 minus 4, 1 minus 6, 1. It would be 0 1 on the x-axis and 0 on the y-axis. 2 1, 5 2, 10 3. So opposite will be 0 1, 0 on the x-axis and 1 on the y-axis. 2 1, 1 2, 1 2 5, 3 10. For each of the following functions, f of x is equal to 3x minus 5, state the domain of f of x. So domain are the values which we can input on the f of x. So we can put any value of x. So it would be minus infinity to plus infinity, and the range would be any output we can get. So minus infinity to graph f inverse x on the same grid. So first of all we need to graph f of x, and then we will graph f of inverse x. So here we will write the values of x and y coordinates. For x is 1, 3 1s are 3, minus 5 is equal to minus 2, 2 6 minus 5 is equal to 1, 3 9 minus 5 is equal to 4, minus 1, minus 3 minus 5 is equal to minus 8, minus 2, minus 6 minus 5 is equal to 3 into minus 2 minus 6 minus 5 would be minus 11. Okay, so let's plot this first. X is 1 and y is negative 2, x is 2 and y is 1, x is 3 and y is 4, x is negative 1 and y is negative 8, x is negative 2 and y is negative 11. So it's something going on like this. This is f of x. What will happen to f inverse x? For f inverse x, we will have x and y opposite, minus 2 1 4 minus 8 1 2 3 minus 1. So minus 2 and 1, 1 and 2, 4 and 3, minus 8, it's going to be something like this, f inverse x. State the domain of f inverse x. So f inverse x also moving from minus infinity to plus infinity, and the range will be again from minus infinity to plus infinity. Graph g of x is equal to 1 by 3 x plus 4. state the domain. So 1 by 3x plus 4 can be graphed as 1 by 3 plus 4. 4.3. 2 by 3 plus 4. 4.604 minus 1 minus 1 by 3 plus 4 minus 1 by 3 plus 12 by 3, 11 by 3, and 9, 3.6, and minus 2 by 3 plus 12 by 3, 10 by 3, 2.3. Okay, so it's going to be 1, 4.3, 2, 4.6, 0, 4, minus 1, 3.6, minus 2, 2.3, this is the graph of g of x. So domain would be minus infinity to plus infinity, and range would be minus infinity to plus infinity. Graph g inverse x on the same grid. So doing the opposite, 4.3, 4.6, 4, 3.6, 2.3, and it goes with 1, 2, 0, negative 1, negative 2. 4.3 and 1, 4.6 and 2, 4 and 0, 3.6 and negative 1, 2.3 and negative 2. This would be something like this. So the domain and the range. If we can plot the points more carefully, it can be 4.3 and 1, 4.6 and 2, 4 and 0, 3.6 and negative 1, 2.3 and negative 2, okay. So domain and range would be minus infinity to plus infinity. Write the equation of g inverse x. So g inverse x is, g of x is 1 by 3x plus 4, so g inverse x would be y is equal to 1 by 3x plus 4. Switching, x is equal to 1 by 3 y plus 4, x minus 4 multiplied by 3 is equal to y. So g inverse of x would be equal to 3x minus 4. Algebraically determine the equation of the inverse of each of the following. So we need to find the inverse. Okay, the first step is switch. If it's f of x, you can write y instead of f of x. Then you can switch. Now switch. Now solve for y. Switch. Extension. Use function composition to verify whether or not each of the following pairs of the function are inverses. So f of x, we need to find f g of x and g f of x. And if we will get the x, it means they are, otherwise they're not. So we need to find f g of x. It's become f of x. Now f of x is 3. Not equal to x. So f of x and g of x are not inverse. This is x now. So x plus 1. This is x now. So g of x is 2 x minus 1. So f of x and g of x are inverses. Spot the error, identify the incorrect algebra in the following problem. Use function composition to verify whether or each of the following pairs are inverses or not. So f of x and g of x, f g of x. Let's find the f g of x ourselves and then we can indicate the problem too. Now this is x, so we need to put over here 2 by 3 x minus 8. Okay. So f g of x is giving us x. Now we need to calculate g f of x. What is f of x? 2 by 3 x minus 8. So now this is x, 2x, gx. 3 by 2 x plus 8. 3 by 2 x plus 8. So solving it is 2233x minus 24 by 2 3 by 2 x, 2 by 3 x minus 8, x plus 8. So x plus 8 was a function to be performed first, because it is like this, x plus 8. So f g of x is equal to x, and g f of x is equal to x. So yes, inverses.